Naturally, to do any of this work requires energy. Energy is defined as the ability to do work. Energy comes in many forms. For example, electrical, mechanical, chemical, radiant, and nuclear. Energy is changed from one form to another as it is used in different ways and for different purposes. For example, this person is using mechanical energy to turn this hand generator to produce the electricity needed to light this bulb. The law of conservation of energy states that energy can change form, but the total amount of energy stays the same. In other words, you can't get more energy from a machine than you put into it. You never get the same amount of energy that is put into a machine out of a machine. Some of the energy is going to be wasted by friction, air resistance, or gravity. Friction wastes a lot of energy. It's friction that wears down your shoes or the tires on your family car. Friction is a force that opposes motion. Objects that are moving have kinetic energy. Kinetic energy is the energy of motion. This skater has kinetic energy. To stop, he must use friction to oppose that motion. So he uses the back pad to drag on the ground. The amount of kinetic energy is equal to the mass and speed of an object. If a truck and a car are going the same speed, it is the truck that has the greater kinetic energy because it has a greater mass. Potential energy is the energy of position. When an object is lifted against gravity, it has potential energy, which is equal to the height of the object times the weight of the object. When someone climbs to the top of a water slide, they have lifted their body against gravity. They have used energy to carry their body weight to this new height. Their potential energy as they stand at the top of the slide is equal to their body weight times the height of the slide. A larger person will have a greater potential energy at the top of the slide because their weight is greater. It would also have required a greater energy to lift that body to the top of the slide. Someone at the top of a taller slide will have a greater potential energy than someone on a smaller slide. When the person goes down the slide, the potential energy will change to kinetic energy, or energy of motion. Roller coasters are designed with potential and kinetic energy in mind. The first hill on a roller coaster is always the highest. A powerful engine is used to pull the cars up the hill. Cars are lifted against gravity, so they are gaining a lot of potential energy. As the cars go down the first dip, the potential energy changes to kinetic. The kinetic energy continues to increase as the cars reach the bottom of the first dip. Then, as the cars go up the next hill, the kinetic energy changes to potential energy, so the cars are pulled by machinery up the first hill only. For the rest of the ride, no engine powers it, just science. That's why the first hill is the highest on the ride. Friction will waste some of the energy of the roller coaster, so every hill must be lower than the one before it. Because of forces like friction and gravity that oppose kinetic energy, there can never be what's called a perpetual motion machine, a machine that runs on its own power. The work that comes out of a machine can never exceed the work that goes in. It may seem that friction is bad, but actually it serves many important roles in our world. It enables us to walk, move, and stop. In fact, a world without friction would be a very unusual place. Look at this computer game with the friction almost turned off. One hit and everything keeps moving. Certainly not the best way to play pool. To help cut down on friction, motors and engines use oil. The oil makes the moving parts of the engine slide past each other smoothly.